For my applied comparative anatomy video, I will be analyzing 3 systems and their specialized functions in the German Shepherd dog. So first off, I should introduce my partner here, and this is Prince. With his help, I'm going to describe some of the specific adaptations that dogs have in their integumentary, sensory, and skeletal systems. Prince is a German Shepherd, which is a breed of the subspecies Canis lupus familiaris. He belongs to the class Mammalia, and mammals arose from pteraspids along the amniote line, and they were small, shrew-sized animals during the Mesozoic era, and it wasn't until the early Cenozoic that mammals began to radiate and become dominant fauna in their ecosystems. Mammals make up several extant groups, but Prince specifically belongs to Eutheria, which are placental mammals. Dogs were selectively bred from wolves, who were very much evolved for hunting with an emphasis on their ability to track and chase prey. Some bigger dogs still keep these adaptations. The mammalian integumentary system is very much specialized around their hair. The mammalian hair is made up of keratinous filaments with outer scales and an inner cortex. The cortex is where the melanin that gives it its color is found, and the differences in the concentration of melanin are responsible for the different colors you can see in his hair, from almost white to black. Scientists are still somewhat at contention when it comes to the original adaptive value of hair. However, one leading theory is that hair first started as small rod-like projections called protohairs that perceived sensory information for the organism. These protohairs would then further develop into structures called vibrissae, and in this view, the insulatory hair that covers Prince's entire body developed secondarily. Prince does in fact have vibrissae. These sensory hairs are his whiskers, and his whiskers can help him navigate or locate objects, so much so that if a dog is tracking a small animal, its movements may displace the air, which can stimulate the vibrissae and aid in the dog's ability to locate them. This is because their whiskers are rooted more deeply in their integument and are associated with nerves that innervate their follicles to perceive tactile information. It's still unknown to us whether pteraspids may have handed down hair to mammals or whether it originally started with primitive mammals. It's a commonly known fact that dogs have a pretty sensational sense of smell. The vomeronasal organ is associated with the mouth and differs from normal olfactory epithelium in that it utilizes microvilli rather than cilia. When airborne particles reach the microvilli, it stimulates the vomeronasal nerves, which then connect to the olfactory epithelium, which then use olfactory nerves to connect the olfactory bulb. The earliest incidence in terrestrial vertebrates of a vomeronasal organ is in amphibians, but it's still present in reptiles and certain mammals today. As previously mentioned, dogs are bred from wolves whose skeletons are very much adapted to be able to move quickly in order to hunt and chase prey. Unlike most terrestrial tetrapods, mammals' acetabellum and glenoid fossas are turned down, with their limbs placed directly under them. This allows them to then run by bending their spine in vertical flexion in order to spring forwards and compress over and over again. You can also see in this video Prince's digitigrade posture, where he stands on his toes, which allows him to increase his stride length. These skeletal adaptations for speed were handed down by early pterapsids and are present in many cursorial species.